Welcome to Trump Wire, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button and turn on notifications so you never miss an update. For centuries, humanity gazed at the stars. First, with the naked eye, then with telescopes that barely hinted at the wonders beyond. Now, the James Webb Space Telescope has transformed our cosmic vision, acting as both a time machine and a portal to distant worlds. Unlike its predecessors, Webb is a revolutionary leap, designed to see the universe in infrared, light invisible to us, but rich with secrets. Its massive gold-plated mirror collects ancient faint light, revealing the birthplaces of stars and the atmospheres of far-off planets. Stationed 1,000,000 miles from Earth, Webb's frigid environment keeps its instruments sensitive to the faintest signals. With this new eye, we're not just cataloging stars, we're characterizing worlds, asking, what are these planets like? Could they harbor life? The James Webb Space Telescope is our guide, transforming science fiction into scientific fact and bringing the cosmos closer than ever before. Every image it sends is a new chapter in our cosmic story. Just over 4 light-years away lies the Alpha Centauri system, our nearest stellar neighbor, a complex trio of stars. Alpha Centauri A and B, both sun-like, orbit each other in a graceful 80-year dance, each shining with its own unique character. Orbiting farther out is Proxima Centauri, a faint red dwarf and the closest star to our solar system. Red dwarfs like Proxima are the most common stars in the galaxy, burning slowly and living for trillions of years. Their stability makes them intriguing places to search for planets and, potentially, life. The Alpha Centauri system is our best laboratory for studying star and planet formation beyond our solar system. Its proximity gives us a front-row seat to the search for alien worlds. Every discovery here helps us interpret what we see in more distant systems. This stellar neighborhood is the cornerstone of our interstellar explorations. It's the first step in understanding our place among the stars. Orbiting Proxima Centauri is Proxima b, the closest known exoplanet to Earth, a world that has captured our imagination. Slightly more massive than Earth, Proxima b orbits its star every 11 days, placing it in the habitable zone where liquid water could exist. But life here would face extreme challenges. Proxima Centauri is a flare star, bombarding the planet with intense radiation. Proxima b is likely tidally locked, with one side in perpetual daylight and the other in endless night, creating a world of extremes. Could life survive? Maybe a thick atmosphere or global ocean could moderate conditions, or a magnetic field could shield it from flares. To answer these questions, we need to probe its environment directly, searching for atmospheric fingerprints and signs of habitability. Before Webb, Proxima b was just a gravitational wobble in its star's light. Now Webb's infrared vision lets us search for clues. Is it a barren rock, a water world, or something else entirely? By analyzing starlight passing through or reflecting off the planet, we can begin to unravel its mysteries. Proxima b is no longer just a data point, it's becoming a tangible place. Webb is turning speculation into discovery. Finding planets around other stars is like spotting a firefly next to a searchlight from miles away. For years, astronomers relied on indirect methods, watching for a star's wobble or the tiny dip in brightness during a transit. The James Webb Space Telescope is changing the game, with direct imaging, capturing actual pictures of exoplanets by blocking out their star's glare. Webb's instruments can reveal planets thousands of times fainter than their host stars, opening up new worlds for study. But Webb's real power is in spectroscopy, breaking down starlight to read the chemical barcode of a planet's atmosphere. This technique tells us what the atmosphere is made of: water vapor, methane, carbon dioxide, and more. For planets like Proxima b, Webb can analyze starlight filtered through the atmosphere during a transit, or even detect the planet's own heat. By studying these faint signals, we learn about temperature, clouds, and surface features. Every photon is a clue, helping us move from detection to true characterization. Webb is turning distant worlds into real places we can study. The search for exoplanets is entering a new era. Webb's extraordinary vision relies on advanced instruments, especially the mid-infrared instrument, or MIRI. MIRI detects the faint heat of cool objects like planets, seeing what's invisible in visible light. To work, MIRI must be kept just above absolute zero, using a special cryocooler to eliminate its own heat. This makes it one of the most sensitive infrared cameras ever built. Paired with MIRI is the coronagraph, a tiny mask that blocks a star's glare, creating an artificial eclipse. This allows Webb to spot the faint glow of planets right next to their stars. Multiple coronagraphs, each optimized for different targets, let astronomers search for planets in challenging environments. By combining MIRI's sensitivity with the coronagraph's precision, Webb can directly image and study exoplanets in unprecedented detail. This synergy is opening a new chapter in our exploration of the galaxy. Webb is not just finding new worlds, it's revealing their secrets. While astronomers anticipated Webb's look at Proxima b, the telescope delivered a surprise: a potential planet orbiting Alpha Centauri A. Using MIRI and the coronagraph, they detected a faint dot, possibly a gas giant, similar to Saturn or Jupiter, orbiting in the star's habitable zone. If confirmed, this would be a monumental discovery, a large planet in the habitable zone of our closest Sun-like star. However, follow-up observations didn't immediately redetect the object, possibly because it was hidden in the star's glare. Confirming its existence will require patience and more observation time. This discovery highlights both the power and the challenges of modern astronomy. Even if this candidate turns out to be something else, the search proves we can now find planets in the habitable zones of our nearest neighbors. The stage is set for future discoveries in the Alpha Centauri system. The James Webb Space Telescope is not the final word in cosmic exploration. On Earth, the extremely large telescope, ELT, is under construction in Chile with a 39-meter mirror, making it the largest optical and infrared telescope ever built. When operational, the ELT will gather more light than all current large telescopes combined, producing images 16 times sharper than Hubble. For worlds like Proxima b, the ELT will offer direct imaging and detailed studies from the ground. Even if the planet doesn't transit its star, it could reveal continents, oceans, and even monitor a planet's daily rotation. The ELT will complement Webb and the upcoming Roman Space Telescope, forming a powerful network for planetary science. Together, these observatories will transform our understanding of exoplanets. The ELT is a testament to our drive to see farther and know more. The ultimate goal is to answer, are we alone? Astronomers search for biosignatures, chemical clues in a planet's atmosphere that could indicate life. On Earth, life has transformed our atmosphere, producing oxygen and methane. Finding similar gases on another world would be a powerful hint of biology. Detecting these subtle signals requires immense sensitivity, where Webb and the ELT work together. Webb can identify planets with atmospheres. The ELT can search for biosignatures with its enormous mirror. Simulation suggests the ELT could detect biosignatures on an Earth-like planet around Proxima Centauri in just 10 hours. It could distinguish between oxygen-rich worlds, barren planets, and prebiotic environments. This ability is crucial to avoid false positives and build a confident case for life. Discovering even simple life elsewhere would transform our understanding of the universe. With each observation, we move closer to answering humanity's oldest question. We stand at a turning point in exploration. The cosmos is becoming a landscape we can map and understand. Webb's first observations of Proxima Centauri and the hint of a new planet around Alpha Centauri A are just the beginning. In the coming years, Webb will survey dozens of nearby star systems, while the Roman Space Telescope will discover thousands more exoplanets. The ELT will soon join the hunt, offering unprecedented detail and shifting the focus from discovery to understanding. We'll build a true atlas of other worlds, complete with atmospheric maps, and, perhaps, the first evidence of life beyond Earth. The synergy of these observatories will define the next generation of astronomy. The quest to understand our place in the universe is a story for everyone. Discoveries made by Webb and the ELT will inspire new generations and change our perspective of home. The stars are calling, and for the first time, we're ready to answer.